So, hello everyone, and I'm Sayam Pathak, and you are watching me on Twitch. So today I'll be talking on Longhorn, and I'll try to run and install and see in the UI how it works and what all offerings it has. So let's see how we do it, and we'll explore. Hi Dan. So let's go to this. So Longhorn is basically a cloud native distributed block storage for Kubernetes. So whenever you try to run the stateful applications, there's a concept of PVCs and PV, persistent volume and persistent volume claim, that for that you can use for persisting your data in Kubernetes clusters, which is very much the use case now. Earlier, it was mostly the stateless applications, but now more and more people have started to move their stateful workloads as well, due to which we have seen a lot of growth in the storage side of Kubernetes. And Longhorn is one such open source project developed by Rancher, and it's pretty good. It is, it comes with your high availability, backup, snapshots, and all those cool features. So yes, it is 100% open source. You can run it on any Kubernetes clusters, and some of its features is basically the highly available persistent storage. So whenever you just create your PVC, you automatically get the PV created, and then you can have your S3 compatible backup, either your Minio or S3 itself, where you can store the backups and take the snapshots, which play a very important role when you are replicating your data, and you are trying to make a highly distributed system, highly persistent system. And yes, cross cluster disaster recovery, so you can just have a re-replicating the entire data. So the options are there. And incremental snapshots and backup, which is a very good feature. And yes, it's a CNCF sandbox project originally developed by Rancher. And let's see the GitHub page. I think this should lead us to the GitHub page, hopefully. Yes. So the 1.1.1 release was out 2 days ago. It's nice. And it has a GUI, so very good dashboard should be there when we run it. And no single point of failure. Again, the backup is good, recurring snapshot. So these features make it very good. And this is how the UI should look like, actually. So let's install this. So it can be installed in several ways, via kubectl, via Helm, and Rancher catalog app. So by Rancher catalog app, they mean when you install Rancher, you'll be having a Rancher UI. So from the Rancher catalog, you can directly install your Longhorn application to the cluster. So in this, we can use either of Helm or kubectl. Let's go with the most easiest one, the kubectl one, and copy this. This looks a bit old, so let's install maybe the latest version, 1.1.1. Let's see if this exists. So what we'll do is we'll quickly go here, and we'll quickly type 1.1.1. Yes, it's there. So it is doing quite a bunch of stuff: namespace, service account, cluster roles, then your cluster role binding. It has a bunch of CRDs that is creating. So you can see the CRDs engine that is, so it should be creating a Longhorn engine. And then do you have the replicas? I think that will maintain the replicas for your how many replicas you want to run for each of your workload. And then in terms of storage, then the volumes, engine image, and then Longhorn instance manager. So this would be the Longhorn manager that should be able to handle all the what all things are getting. If the PVC is getting, it has to get the PV. If the backup and all is configured, then it does that, all sort of things. Then backing image manager and bunch of other things. And yeah, another daemon set. So this is great. So Longhorn manager would be running as a daemon set. This is interesting. So Longhorn, this is the most And this is the real thing. So you have the Longhorn Manager 1.1.1, which will be running as daemon set. Daemon set means that it will be running on your on each of your nodes in the Kubernetes cluster. So that's what it means. Okay, so sorry for that. Now the image should be big enough. Okay. So now what we will do is, so yeah, so what I was saying is there are a lot of different components that Longhorn will deploy onto the cluster. The good one is the daemon set, and it runs with all your instance manager, share manager, and all those arguments that it takes, and then the ports, mount paths that it takes. This is interesting. And it has some of the environment variables as well. Okay, and it creates a service as well. So it creates a cluster IP service, and then you have the Longhorn UI as a deployment. So the Longhorn UI that we'll be exploring, it comes as a deployment. So you can see it comes as a deployment in 9500 port is there, and then front end UI service, and then you have a Longhorn driver deployer. So there are a lot of different components that it deploys. So I think it should take a lot of resources as well, at least a minimum set of resources. So it should not be working just on a very small clusters. So it does take quite a lot of resources for deploying. So let's take this YAML file, the raw YAML file, and see. We just have to do a kubectl apply f. So for today, what I have done is, let me just share my command line so that you can see what is happening inside the cluster. And I'll share the screen to application window. Okay, this should be it. Yeah. So you should be able to see that I have already a 3-node Kubernetes cluster, which is K3s, and it is running. I mean, it should be old right now. So it should be quite a few hours while this cluster was created, I believe. Anyway, so it doesn't have any workload. So you can see, oops. Yeah, it do not have any workload. So it's a default with your traffic installed and local path provisioner that comes, and the code DNS. Actually, what we can do is K3s comes with local path provisioner as a storage class. So we'll delete that so that we do not have any confusion. So because that comes as a default one. So kubectl delete sc local path. Okay, it's deleted. So what we'll do now, kubectl apply -f, and we are deploying the latest branch, Longhorn 1.1.1. So yes, it is creating namespace, service account, roles, lot of CREs, engine replica settings, volumes, engine images, nodes, instance managers, share managers, backing images, backing image manager, then a config map with the Longhorn settings, which we can change, I think, pod security policies, and it has role for that and role binding. I think that should only be created in the namespace. Then a config map for the storage class, daemon set for the Longhorn Manager, deployment from the Longhorn UI, and 2 of the services for Longhorn backend and frontend, and then the Longhorn driver deployer as well. Wow, quite a lot of things. So kubectl get ns. I think Longhorn system should be the namespace. Yes, it is. So let's see what all is created. Get pods, -n. Yeah, also I can watch it and see what all things get created. Sit back and relax and have a cup of tea or coffee or water. Anything is fine. So Longhorn is getting deployed. Bunch of other things as well, like the CSI provisioner, snapshotter, and instance manager for all the nodes is getting deployed. And then you have, this is also running, I think, on all the nodes because I can see them 3 manager, three. It's a 3 node cluster, by the way. So that is interesting. We'll do a control C. I think most of the things are running. CTL, we can just see once. Everything is ready. Yes. So we have everything ready. What we'll do is we'll do kubectl get svc -n long on system. And the thing over here is we have a long on front end, and I would like to explore it more. So kubectl edit svc. You can create an ingress, but just let's do it for now. And I'll change this to output. Okay, let's see now which node port it is so that I can access it from the UI. Let me open it and then I'll switch back the screen share to the UI. Give me a second. So you should be able to see the Longhorn UI right now. So we have just deployed Longhorn onto a Kubernetes cluster, a fresh Kubernetes cluster. It didn't have anything. So as we have seen that Longhorn is a distributed storage solution for your Kubernetes clusters. And architectural wise, it's a big architecture, but let's try to see what it is. So you have a pod, and it says you have a Kubernetes volume, and then you'll be having a engine which is deployed, and we can see, I mean, we have seen the engine as a daemon set which is running. And each of them, then we specify, I think, the replicas, and it takes the nodes SSD or the external disk as well, if defined in the config file, but by default it will take the node storage, which is the SSDs, and do the replication as defined. So I think when we create, we can define the set of replicas, I think. So if I go to the volume, I create a volume, and yes, we can specify the number of replicas, and that's what is mentioned over here. So as many number of replicas, they'll try to map with different SSDs, I mean different partitions basically. So you can use the partitions over here very in a very good way. So in the figure below, there are 3 instances with Longhorn volumes. So there are 3 instances with Longhorn volumes. Each volume has a dedicated controller. So every volume will give you a dedicated controller. So if I create a volume from here, so it'll be managed by a dedicated controller. Okay. Next is each Longhorn volume has 2 replicas, and each replica is a Linux process. Interesting. So each replica over here refers to as a Linux process, and by default I think it is saying that for this particular figure it is saying that it is having 2 replicas. So you can see 3 over here and 6 over here, but you can define them. So when you create over here, you can define the number of replicas. And then you have the arrows in the figure: read write data flow between the volumes, controller instance, replicas instance, and then the disks. So volumes, the controller instance, replica instance, and the disks. So that's how it is going. Then by creating a separate Longhorn engine, so separate Longhorn engine for each volume, if the controller fails, the function of the volumes is not impacted. So that's the reason I think that they have mentioned. And the engines and the replicas are orchestrated by Kubernetes. This is super interesting. Longhorn Manager pod runs on each node. So Longhorn Manager is a pod that runs on each node as a daemon set, which we have seen when we deployed the cluster. And it is responsible for creating and managing volumes and handling the API calls from the UI or the volume plugins for the Kubernetes. So this particular thing over here in the UI, we are seeing the volumes. Obviously, right now I do not have any workload running, so this is just a bare volume that it is there. So, and these are the set of nodes. It is saying that it is ready, and I think we can dedicate the nodes as well. So we can add tags. We can disable the node scheduling for the volumes, and this is the mount path for var lib Longhorn. And this is the default disk name that has taken, storage size which is available. We can give a disk tag as well. A lot of interesting things that we can do. And then overall dashboard is pretty simple, and these are I think the set of events that happens when you from the Longhorn system namespace. So these are the set of events that are happening from the Longhorn system namespace. And 3 nodes, and we do not have any volume, and so this is something that we can definitely have a look at. Next up is the backup. So error listing backups, backup target is empty. Yeah, that is a very genuine error, because I do not have any backup targets as such. So it should give this error. So what we'll do is we go to the settings. So I think the config map that we saw for Longhorn, which gives the default settings, is coming is representing these set of settings. So there are tons of settings over here that must be defined in the config map, which was created as a default config map. So what we'll do is we want to explore basically what the end goal for this session is, that I want to deploy a pod which is attached to a PVC, and PV should automatically be get created, and everything should be showing in Longhorn, and I should be able to take the backups and the snapshot. Sounds simple. So let's see how we can do it. Okay. So you have Longhorn Manager, then you have Longhorn Manager, we already discussed. Now Manager communicates with the Kubernetes API to create a new Longhorn volume. So Manager will communicate with the API server. API server is the main component, the brain of the Kubernetes running in the control plane. And then you have it always watches for the API server response and creates all this stuff. Then Longhorn Manager is asked to create a volume. It will create the engine and attach it to a volume. We have seen that every volume is having its own engine, and Longhorn engine always runs on the same node as the pod that uses the Longhorn volume, and it synchronously replicates the volume across the multiple replicas. Now engine is responsible for replication, as we can see in the diagram as well. So I think we are pretty good with the architecture. We are able to understand the terminologies. We are able to understand what all things get created. The engines, the volumes, and the engine will be on the pod where the volume is running. Engine is, then managing the replicating the data. All these things are pretty straightforward. Now what we'll do is, okay, so you can see now the screen should be full screen and it should be available. So vi pvc.yaml do is we'll set the storage class mode manually to Longhorn, and kubectl create -f pvc.yaml create. Okay, get pvc. Now at least the store. Okay, awesome. So we can see PVC automatically got bound. We had to mention the storage class. What we can do is we can actually set it as a default storage class. Since it was a K3s cluster, and K3s comes by default with local path, which was the default one. So there is a command to do that as a storage class, to set it as a default storage class. So, but in any case, either you can do that, or we can just specify the PVC in the PVC that the storage class should be Longhorn. So that's what was missing, and we have fixed that. So kubectl get PV. If we do a PV, we can see a PV was also created immediately, and I didn't create the PV. So kubectl get pods. Let's see if the pod is running. Yes, our pod is running. Now let's head over to the UI and see what is happening in the UI. So we go to Longhorn UI. We can see one volume, which is very healthy, which is green color. It's very good. I always love this color when it's healthy. Things are working as expected. So we have a healthy pod, and it's a PVC, and you can see the namespace, and we can see it is attached to task PVC pod on this particular node. So it already defines, gives me all the information which is required. Now, so this portion works. Now what happens is, how about the backups and the snapshots? So what I can do for that? Okay, still I cannot create the backup. Now for the backup, what we'll do is we need to specify. If we go to the general settings, I'm sure there must be something where we specify the backup location. So it should be backup. So this is the place where we define the backup, and we have to give two things. One is the backup target and the target credential secret. So endpoint used to access backup store, NFS and S3 are supported. Okay, set up a backup target, which is good. This is what we need. Set up a AWS S3. I don't want to go with cloud. I will use Minio. Okay, it should be somewhere down. Yeah, so I want local testing, which should work fine for my use case. It is fine. So we provide two testing purpose based on NFS and Minio S3 server for testing. Use the following command to set up Minio S3 server for backup store after Longhorn system was created. So we already have Longhorn running, so I think we can easily run this. And this also let's run for v1.1.1. We'll just check if that exists and we then apply it. So v1.1.1, yes it does. So let's create a menu server. So kubectl create -f. So it created a few secrets and it created a pod and a service, which is fine. Now what to do? What to do? Where are you? Documentation. Come on. Okay. Now in the settings backup target, set it to this. Okay, I'll set it to this backup target. Done. Okay, credential secret is Minio secret, I think. Still we'll double check. And credential secret is Minio secret, which was already created. Now it should, it's all. I think that's it. So we'll save it. And we can see the Minio pod is running. Cool. So this looks good. This looks good. Now let's go back to our volume and we will click this volume. Okay. So this volume has a characteristics. It has three replicas, which is running on different nodes, as I can see, and under the slash var lib longhorn on that particular node, it's running fine. Now what we'll do is snapshot and backup. So we will create a backup. So let's see. This could take a while depending on the actual size of the volume. Okay, I see we have a backup created, which looks good. And if I go to the backups, I see a PVC backup is already there. And we can restore the latest backup. If I delete the volume, yes, because we want to test if the backup works. So the volume gets deleted. We still have the backups. Okay, so this is interesting. Now, suppose the volume gets deleted. And what do we do now? But we have the backups with us. So what we'll do is we'll restore from latest backup. We'll click OK. And we should see our volume appearing again and attaching to the pod and the PVC, which is amazing. So that was the task, right? We wanted to we installed Longhorn. We had our pod. So we installed Longhorn. We explored the UI. It has a dashboard, nodes, and the volumes and the backups. For the backup, we configured the menu, which is for the local testing. Obviously, you can have your external NFS server or the S3 bucket for the more realistic use cases. And after that, we have our pod, I mean the PVC, and we have the volume that we created, and we created the backup, and we deleted the volume, and we were able to create the volume again for the deleted volume. We were able to restore from a backup. So the restore process is actually pretty simple. You just go there, select the volume, and you just restore. Cool. So that's what it is. I mean, obviously there is a lot. You have your volumes and nodes. You can just size it, and I mean, the major features would be this. Yeah, you can also set up a Prometheus and Grafana for monitoring Longhorn. I think which would be good because it has a metrics with the Longhorn Manager IP. So if you go to the Manager IP/port, we should be able to see the metrics for that. So the installation steps are pretty straightforward for that. But I think I'm pretty much about time. I mean, the streams are mostly expected to be 30-35 minutes. But since it was the first one, I couldn't calculate much how much time it will take. I would never be able to do that because we don't know how much time it will take. So the goal was to create a PVC, I mean, to create a pod and attach it to a volume, a Longhorn volume, and then explore how the backup works and restore from a backup. So works pretty well. And I think it has we can have a CSI snapshot as well. So to enable that, you have to do the CSI snapshotting. Actually, I have shown that process. So Cubester, so there is a learn guide that I posted on Cubester. So in this, I have actually told how to enable the snapshotting for snapshot controller for Longhorn. So this is how you uh, install the common snapshot controller, which is actually the Kubernetes snapshot controller. And you after that, once you have the controller, you create a custom resource of which is specific to Longhorn. So that's what happens. And yeah, pretty much simple to do that as well. Okay, so what we'll do is now I'll stop share the screen, and thank you everyone for joining in, tuning in, and listening to the Longhorn talk. Obviously, I think it stays on Twitch for 15 days. After that, I'll try. I don't know if I'll just trim it down some portions and upload to YouTube. I mean, let me know in the comments if you want that. We can do that. Else, it is just a pain. So don't want to cut, crop so many things and post on YouTube. So thank you for joining, and hope you learned something today. I learned a few things about Longhorn, and hope you were able to learn as well. Thank you. Bye.